Okay, this is my driver. Here, let's zoom in a little bit. There we go. Okay, so we've got a TL494 basic oscillator. It's got two outputs, okay, and each output goes to a hex inverter. This really isn't necessary, but it does do a lot to help clean up the waveform. Okay, so then, and not only that, it gives me 7 outputs. So, you know, if I wanted to run like a full bridge or something, I could do that easily with the hex inverter. It changes from 2 outputs to 7. So I'm only utilizing 2 of the outputs here, and each one goes into an octocoupler gate driver. Now these provide isolation from the IGBT to these 2 ICs here, and they run 5 amps to the gates, the gate and the emitter. So pin, what would this be, 5, 6, 7, pin 7 would be your output going to the gate, and then pin 6 would be the output going to the emitter. They've got a little decoupling capacitor here, 100 nanofarads. And then I'm also using the caps. These 2 caps are connected in series, okay? And then the positive pin goes to 8, and then the negative pin goes to 5, okay? And where they're connected in series would be the center tap. That actually becomes the new output going to the emitter, okay? It's called negative gate drive. Alright, so then I've just got 2, you can see, 2 10 kilo ohm caps across the gate and emitter, a couple of ferrite beads here, and then 2 caps, and that goes up to my half bridge here, my half bridge module. Now I got like some cheap caps here. You can use better caps if you want. And that's just my bank. So we can look at the, oh yeah, and each one of these is powered with 24 volts. Each one of these is a separate power supply. Very important to use a separate power supply and not power them with the same power supply, or you'll get a short and these things will burst, they'll explode. Same thing with a full bridge. If you're going to use a full bridge, you'd have 4 of these, and each one would have its own separate power supply. I'm talking no ground, nothing. Nothing can be connected. It has to be completely isolated. Alright? So I'm going to put my little heat sink back on there. And you can look and see I've got 19 kilohertz. If you run it at low power and just set a little neon lamp there, it'll light up when you get the right frequency. So now we can get to the good part, the arc. So we're going to turn up the voltage. There, that's about 90 volts AC. Look at that. Very impressive. Alright, let's turn the voltage down. Oh yeah, and you can have a cap bank. You can see my wires. I need to get thicker wires. They're smoking because it's a lot of current. I need to do something about that, but it's good to put a cap bank across the 2 terminals there. And that's pretty much it. That is this is an SKM 300 amp brick being driven at 13.6 kilohertz. That's it.